Hi everyone! Today, we're going to discuss about method of sections for analysis of simple trusses. So in this method, we will cut the truss into two sections by passing a cutting plane through the members whose internal forces we wish to determine. This method permits us to solve directly any member by analyzing the left or the right section of the cutting plane. To remain each section in equilibrium, the cut members will be replaced by forces equivalent to the internal load transmitted to the members. Each section may constitute of non-concurrent force system from which three equilibrium equations can be written. And these are the summation of forces on the y-axis, the summation of forces on the x-axis, and the summation of moment, which are all equal to 0. Because we can only solve up to 3 unknowns, it is important not to cut more than 3 members of the truss. Depending on the type of truss and which members to solve, one may have to repeat method of sections more than once to determine all the desired forces. So here's a sample problem to have a deeper understanding of the method of sections for analysis of simple trusses.
Hi, good day. So I am here today to solve a problem involving analysis of structure using methods of section. So now let's solve the problem. So our problem for today is to use methods of sections to determine the force acting in members DF, EF, and EG of the Howe truss described. So here's our diagram. So this is the DF, EF, and F, and EG. So, if we're going to redraw that, so we will have this one. So first, let us start to solve for this, for the forces here on the roller and the pin. So, on the pin, we have HX and HY. And on the roller, we have AY. So, if we're going to for the summation of moment on point A, we will solve for HY. So, summation of moment of A equal to 0. So, we will have HY times the distance, so 40. So, it's positive because, it's negative because it will go counterclockwise. And then we will have plus the 400 pounds times the distance 30 plus the 1000 pounds times the distance 20 and the 600 pounds times the distance 10 equal to 0. So if we're going to compute that, for that, we will have HY is equal to 950 pounds. So now, we'll have DF, EF, and EG. So we will assign if it is compression or tension. It's okay if you will assign a different force than me because we will only have different answers on the sign. And the sign just means that your answer should be on the opposite force. So for DF, I'm going to assign that it is compression. So compression. And for EF, I will assign that it is also compression. And for EG, tension. So for that, we're going to have this diagram. So as you can see, I cut the section here. So if you will cut a section, you should only cut 3 members. Not 4, not 5, only 3. So here. So we're going to solve for that. So now, I'm going to solve for the member DF, for the force of the DF. So I'm going to have a summation of moment in E in order to do that because the other forces will pass through E. That's EF and EG. So the forces that will remain are the 400-pound force and the HY. We already have a value for HY, so we can solve for DF. So summation of moment in E equal to 0 would be HY times the distance 20. So HY is counterclockwise. So let us just put the counterclockwise on the left side and the clockwise on the right side. So equals the 400 pounds times 10 plus DF. DF, we will going to solve for the DFX because the DFY will pass through E. So DF cosine 60. So if you know your trigonometry, so we have a 30 degrees here, so we have 60 degrees here, and if we will have so here we have 60 degrees because we have 30 degrees here. So if we have this line, we'll know that this is also 30 and this complement of this is 60. So we have cosine 60 times 20. So computing for that in your calculator, you're going to have DF is equal to 1,500 pounds plus our assigned force compression. So if your computed value is already on the positive sign, that is the true force. The force that you assigned is already correct. So if it's negative, you will have to put it on the you will have to change it to tension. So next is to get the next I will get the member force for the member EF. So we're going to do that. We have to have a summation of moment in H equal to 0. So we're going to do that. So moment of H, we have EF. So here is the EF. So moment in that. So we're going to have 400 times the distance 10 is equal to EF sine 30 times the distance 20. So computing for that in the calculator, we're going to have EF is equal to 400 pounds compression. And lastly, for EG, we're going to have a summation of force in MF. So equal in point F equal to 0. So for EG, so the other forces will also pass through point F, so we will have EG left. So okay, let's do this first. So HY times the distance 10 is equal to EG times its distance. So it is this one. So let that be the distance x. So we have an angle and a distance. So if we will compute for that, we're going to have tangent theta, which is 30, is equal to opposite x over the adjacent side 10. So x will be equal to 10 tangent 30. So that will be the distance. So going to put it here, 10 tangent 30. So computing for that in your calculator, so EG will be equal to 1,645.45 pound tension. So there we have it. We have the members EG, EF, and DF. So there. Thank you.